Hi, hello students, welcome to Let's Understand Physics. In this video, we do electricity chapter revision for class 10 students. Previously, in two videos, we have done combination of resistors problems. Now in this video, we see based on Ohm's law graph, and we do how to calculate the electricity bill for houses. Okay, so let's see. These two questions are asked in 2023 CBSE board question paper. Okay, so first question, how is electric current related to the potential difference across the terminals of a conductor? Draw the labeled circuit diagram to verify this relationship. So here what are they asking? They are asking you to tell the relation between electric current and the potential difference. So how they are related to each other. So from where you will get this relation? By using Ohm's law, you should be able to tell the relation between potential difference and the current. So they are asking you to draw labeled circuit diagram. That means you have to draw diagram of Ohm's law itself. Okay, let's see. Now what is the statement of Ohm's law? You have to write first. So statement is, Ohm's law states that the potential difference across the circuit is directly proportional to the current passing through it. V is proportional to I. So to remove this proportionality, we have to take a constant. We take that as R, which is resistance. So V is equal to Ri. That simply we write it as V is equal to IR. This is the statement of Ohm's law. But while writing statement of Ohm's law, you must mention along with this relationship the physical conditions such as temperature must be constant. That is very important. That can be asked for one mark also. They will ask you, when is the Ohm's law true? When the Ohm's law will be true? Whenever the temperature is constant. That you must include in the statement. Understood? So how do you write? Ohm's law states that the potential difference across the circuit is directly proportional to the current passing through it, provided the temperature remains constant. Okay, then you have to write this formula. Then they are asking you to draw the circuit diagram. So circuit diagram of Ohm's law we draw by taking first the supply cell with positive negative terminals, and then here you have to take a rheostat which is variable resistance and which is used to change the resistance of the circuit by changing the position of this knob. This knob can be changed. Okay, now you have to take ammeter to measure the circuit current, and then take the resistance. This is fixed resistance, and then across this fixed resistance you have to take the voltmeter. So you have to take positive negative for voltmeter and ammeter as well. Understood? Plus minus plus minus. This is the resistance, and this is the potential difference across the supply. This is the rheostat, or you can say it as variable resistance. When there is supply connected, there will be current passing through the circuit. Understood? So from positive terminal to the negative terminal, the current passes in the circuit. So this is the detailed circuit diagram labeled. You can draw for the circuit diagram of Ohm's law. Okay, understood everyone? Practice this neatly so that you will get out of marks when you attempt this question in the exam. Now let's see second one. Why should an ammeter have low resistance? Ideal ammeter will have zero resistance. That also you have to remember. That question also may be asked in the exam. Okay, so ammeter should have low resistance because it needs to measure the entire current, complete current passing in the circuit. So this current is measured by ammeter itself. So it should have low resistance. If ideal ammeter, then it should have zero resistance. It should not have any voltage drop across ammeter. Understood? So that is the reason. Next, let's go for third one. So if you observe here, this is question 2023 previous year. Okay. Now third one, two VI graphs A and B for series and parallel combinations of two resistors are as shown. Here if you observe graph A and graph B, you can observe the coordinates, voltage and current. Okay. Giving reason, state which graphs shows series parallel combination of the resistors. But that here they have given small a small b. That doesn't mean A will be series and B will be parallel. Understood? In this graph, you have to identify and tell which is series combination graph and the which is parallel combination graph. Understood? Now how do you find it? You know, resistance in series will be R1 plus R2 and so on. Then parallel, if we take R1 and R2, RP will be equal to R1 R2 by R1 plus R2, isn't it? Then in comparison of RS and RP, which will be greater? We know RS will be greater than RP, definitely. So whichever has more resistance, it should have less current, isn't it? So from this relationship you can say IS will be less than IP provided V is constant, same potential difference. Okay. Now observe, how do you take this? For same potential difference, just draw a perpendicular like this. Then you can take perpendicular from current as like this. Then you mark I1 and I2. So I1 is current for A combination and I2 is for B combination. So if you observe from graph, I1 is less than I2, isn't it? I1 is less than I2. So compare now these two relationships. I1 is IS, I2 is IP. So I1 is IS, that means that is series combination. So A is series combination for us and B is parallel combination for us. So this type of question is also very important in the board exam. You can solve like this. Okay. Even for MCQ they can ask you from graph based question. Understood? Now let's see next one. Second question A. Define electric power and state its SI unit. The commercial unit of electrical energy is known as unit. Write the relation between the unit and joule. Now see, define electric power. So what is the definition of electric power? What do you say? It is the rate of consumption of electric energy. We can say like that, because power is equal to work or energy by time. So here what energy? Electrical energy is consumed in given time, then we say it is power. What is its SI unit? Electric power SI unit is watt. Its SI unit is watt. When you are writing completely, you have to write small letter and then capital W is the unit symbol. Okay. And then electrical energy commercial unit, what we call it as unit. That unit and joule, what is the relationship they are asking? Okay. Now we have one more formula for power, isn't it? What is that formula? Power is equal to VI. Then from here, for voltage, what is the unit? Volt. For current, it is ampere, isn't it? So 1 watt will be equal to 1 volt ampere as well. Then from this formula, energy is equal to power into time. You can say energy equal to power into time. Then power is equal to voltage into current into time. You can write VIT. So here time in seconds. For energy it is 1 joule. Then for power you can take 1 watt into for time it is 1 second. Okay. Watt second you got. So you can simply say 1 joule is equal to 1 watt second. But watt second is not the commercial unit of energy. The commercial unit of energy is kilowatt hour. Understood? So this is the commercial unit. Now by using this watt second, can you convert into kilowatt hour? Yes, we can convert. How do we convert? We'll see now. 1 kilowatt equal to 1000. Kilo means 1000, isn't it? Kilo means 1000, so I can write 1 kilowatt is equal to 1000 watts. And then after kilowatt we need into hour, but we have in second. So what we will do? 1 hour is equal to how many seconds? 60 minutes into 60 seconds, isn't it? So 3600 seconds. Then these two we will substitute in that by just changing them into, let's see, from here 1 watt will be equal to 1 watt will be equal to 1 by 1000 kilowatt. In place of 1 watt, what I will write? 1 by 1000 kilowatt. In the same way, 1 second is equal to what I write? 1 by 3600 hour. Now, how much I got? 1 joule is equal to 1 watt second. So 1 joule is equal to, in place of 1 watt, what I will write? 1 by 1000 kilowatt into 1 second is equal to what I write? 1 by 3600 hour. Now this 1000 and 3600, if I send to the other side of equal to, both of them will go to the multiplication. Understood? Now I can say 1000 into 3600 joule is equal to 1 kilowatt hour. Now this will be 36 into 10 to the power of 5 joule is equal to 1 kilowatt hour. We know multiples and submultiples, isn't it? We have names for them. So 10 power 5 doesn't have any name, but 10 power 6 has a name. If I have to get in place of 5, 6, then I have to take point here in 36. So it becomes 3.6 into 10 to the power of 6 joule equal to 1 kilowatt hour. So this is the relationship we have between commercial electrical energy unit, which is kilowatt hour, and joule. Understood? Very, very important. You have to remember this. Okay. Now let's go for next question. Question B. In a house, 2 bulbs of 50 watt each are used for 6 hours daily, and an electric geyser of 1 kilowatt is used for 1 hour daily. Calculate the total energy consumed in a month of 30 days and its cost at the rate of 8 rupees per kilowatt hour. So this kilowatt hour is what? Commercial unit of energy. Now here what are they asking you to find? Electricity bill. In every house we can find electricity bill by using this calculation now. Okay. Depending upon our devices, we have to convert into kilowatt hours. Okay. Let's see how do we find it. For this, for my students, I used to teach like this. First, just make the table. Okay. So like this, one table will make. Okay. Combined table you can by using just a scale. Now you can observe serial number, name, number of devices. Okay, the same device, how many number they have given, and then wattage reading, then total watts we will find by using this number. Kilowatts we have to convert it, and then time for which they are using that device, and then finally kilowatt hour. Okay, now let's see in the question. Two bulbs. So number of device here you have to take 2. Name is bulb, and each has watt reading 50 watts, and then time 6 hours. So all the data is given. We just need to write in this table. Serial number 1. Name I am just writing it as B because bulb. How many are there? 2 are there. Each is 50 watts, and then total watts will be 2 into 50, 100 watts. So when you have 100 watts, you have to convert it into kilowatt. You have to do divided by 1000. So 100 by 1000 will become 0.1 kilowatt, and then for 6 hours it is used. So what is the total kilowatt hour? For that you just need to multiply this column kilowatt and the time. Okay, so 0.1 into 6 will become 0.6. That's all. And then second one, they have given geyser. There is only one geyser, and the power rating 1 kilowatt. Directly they have given in kilowatt, so we need not to convert. And then time, it is 1 hour. Generally they give the time in hours only, so you need not to worry. Only when they give in watts, then you have to convert it into kilowatts. That is important. But here they have directly given 1 kilowatt I have written, and then time is also 1 hour. Then it becomes how many kilowatt hour? 1 kilowatt hour. Now here we just need to find total kilowatt hour. That's all. Total kilowatt hour will become 0.6 plus 1. 1.6 kilowatt hour we have total consumption. Now what is the cost we have to find for 30 days they told. So cost or bill will be equal to total kilowatt hour into number of days into cost of 1 kilowatt hour. Okay, so what we are finding? Bill amount, bill cost we are finding. So how do you find kilowatt hour? Into number of days into cost of 1 kilowatt hour. So total kilowatt hours we got 1.6 into number of days 30 into 1 kilowatt hour cost they have given 8 rupees. So if you simplify you will get 384 rupees is your bill. Understood? So share this video to your friends and family so that they will understand how to calculate their own electricity bill for their house. Understood? So don't forget to subscribe. Thank you for watching.